Hey guys, in this video I'll be going over the problem rotate image. So in this video I'll be going over what the problem is asking, explaining the solution behind it, how to implement it, and then wrap up with the runtime analysis. So I will actually say my solution for it is quite, it's a little tedious that you have to type out a decent amount of stuff, but it's really easy to understand and there's very little chance of bugs going wrong. So yeah, and it's also very fast. So, which is why I still think it's a good solution to share with you guys. So let's get into the problem. So here you're given an n by n, so a square matrix, and you have to rotate the image clockwise. And you're not allowed to allocate any new anything new like arrays or anything like that. So yeah, it's best to see what they mean with an example. So if you have an array that looks like this, like a 2D array, then if you imagine just rotating the square 90 degrees clockwise so that it flips over on this side, then it would look like that because essentially you are turning it 90 degrees. So yeah, another example is here. So after you rotate it, this 15, 13, 2, 5, that would be at the top here. And then this 5, 1, 9, 11 would be this column here. And yeah. And the matrix is that big, but it doesn't really matter because this solution is pretty general. And yeah, let's just get into explaining the solution. So to start off, we can first break this problem down into multiple different subproblems. So in their example, let's just look at this example for a better idea. So you can rotate this entire layer here, which is like the first layer from the outside. And then after you rotate that, then you can rotate the inner layer. So you can essentially break this into a problem where you have to rotate every single layer, because if you look at this, the outside layer is rotated and then the inside layer is rotated as well, just because like that's how the rotation works. So how exactly can we rotate each layer? So now we know that we need a function that can rotate a layer. So yeah, so what we want to do is we want to go through every single spot in one of the sides and perform a rotation. So what do I mean by that? So basically it's just really, it's kind of hard to explain, but I'll try to show you guys with an example. So if you notice how rotation works, it's that this moves to this spot, this one moves to this spot, this one moves to this spot, and this one moves to this spot. So you want to start at this one and perform this rotation. Then you want to go through this one and perform the rotation. And this one will rotate at this spot, then this spot, which is like the next one, and then this spot, and then this spot. And you might be noticing a pattern here, and it's that we can actually pre-compute these spots. So what we want to do is we want to just loop through all of this. We don't want to take this one because this guy is counted in this guy's rotation. So we want to start from this guy, loop to this guy, and perform this like circular rotation at this spot, this spot, this spot, this spot. Then the entire layer of this matrix, like this outer layer, and this entire layer will be rotated. So let's declutter this a little bit. So how do we pre-compute which of these squares belong in this like sort of 4-cycle rotation? And it's just a pretty simple pattern. So at the start, your row will always be equal to 0, and your column, let's just call this I. So that'll be your first square inside this 4 rotation. And then the next square inside this rotation, well, you know your column will be on this edge here no matter what. And so then your column will be the length of this. So let's just call that length. And your row will be what the column was previously. Because let's just say this is column 0, then the row here will still be row 0. This is column 1. This will map to the first row number 1. It's just how 2D array works. And then the third one, you'll have the length will be the row, and the column will be the length minus I, because instead of going I amount of steps in this direction, you're just going I amount of steps in this direction. So think sort of like kind of like this type of shape, right? And then similarly with this spot here, you can calculate it by, well, you know the column will be 0 and the row will be length minus I. And so what we can do is we can loop from I equals to this one to I equals this one and rotate this layer. And this can also be really easily generally applied to shift any layer. So there are probably multiple ways to do this, but in my solution, what I do is after shifting the outer layer, let me just get a new thing here. After shifting the outer layer, so let's just say this is the outer layer. After I shift the outer layer, I know I want to shift this inner layer right here. What I can do is I can just pretend like, let's just say this outer layer has a length of 5. So this is like a 5 by 5. Then this inner one will be a 3 by 3. So I can just, because on each side you're minusing 1 unit of width. So this will be a unit of 3. So then I can just run, I can just run this algorithm here, except instead of length equal to 5, instead of looping from I equal to 1, like 0, moving for 0, 1, 2, and 3. Instead of doing that, I'll just be doing it, but with 2 numbers less. So I'll pretend this is a 3 size, and then I'll go through here. And then, and then what we can do is we can just shift all this over by the layer. So what essentially I'm doing is, instead of worrying about your kind of array indexes getting all messed up because this is kind of squeezed in here, what I do is I essentially pretend like, so say this is the main one. So after I finish this first layer here, what I will do is I will pretend like the next layer is just a smaller box like this, and then I will just transform this little box by shifting it over 1 unit this way and 1 unit this way in both directions, and then the box will essentially look like this. So then you can perform the rotation inside this box here. And you just keep on rotating that and until you run out of layers to rotate. And the last thing to take into account here is how many layers we need to rotate, and it's pretty easy to pre-compute this by just dividing the initial length of the initial layer by 2, because every time you rotate you are cutting off 1 from all the sides. So this will be first n by n, and then it'll be n minus 2 by n minus 2, and then so you can just divide this by the original thing by 2 to know how many layers you have to rotate. And so let's just get into how the solution is actually implemented. So let's make this a little larger, and I'll just copy over what I have in the original method to avoid having to type it all out. So this is what our rotate method will look like. I just grab how long the matrix is, like the outer layer, and then we know there will be n divided by 2 layers, so we will rotate all these layers. So we'll rotate the ith layer, so we'll call rotate layer and the layer that we're on, and we'll just give it our matrix to rotate. And so our rotate layer function will look like this. So this might be a lot to take in, but I'll break it down. So this is our length of this current layer. So because each layer takes away 2 from either like length, so we know that the length will be the original length minus how many layers we're on. So this will be a 3x3 box essentially that we'll need to rotate. And what we do is we just go from I equals 0 to the length here minus 1. So what I'm saying is it'll let me just grab a pencil here. Not exactly sure how to use this software. Alright, I think I got it working again. So essentially what you're doing is you're looping and you're rotating this one, then rotating this one, just like we described earlier. And so you will go from here to that, and here is just doing that little the square thing that we can do to pre-calculate our cycle of 4. So you can ignore this layer thing for now. So we know that row will initially be 0, so you can think of this like a 0 plus layer, because this layer here is our translation. So we're first pretending like if this is our original matrix, this is our submatrix, and then we are translating the submatrix over by 1 and down by 1 to make it look like this. Yeah, so basically this layer here is essentially just shifting our like smaller submatrix. And so this part here is really what's actually calculating these which elements belong in the cycle, and it's pretty much exactly what I described earlier. So you know first the row will initially be at 0 and the column will be at I, and then the next guy in the cycle will have a row that's equal to how many columns this I shifts over, and you know that the column will be all the way at this end here. And then the next one, you know the row will be at the end, and the column will be shifted over I units from this side. So instead of being shifted over I units from this side, so kind of like this sort of thing. I'm not drawing it very well, but yeah, so that's exactly what we calculate here. The row will be the last guy, and the column will be that shifted over I units from the right hand side, and then the last guy will be you know that the row you will shift up I, because here you shift down I, so here you shift up I here, and so that'd be this thing, and the next column will just be 0, but we add layer again just to transform this little matrix, because you know the column will be on this edge. And then, so now that we know this matrix, we can just shift it over by translating inside of this larger matrix. And then it's just a simple matter of performing the rotation. So you want to swap. So here I just save all these integers to make it really easy to understand. So this is the first like integer inside the thing we're rotating. This is the next one, this is the next one, this is the next one. Then the next thing we swap will be equal to the first integer. The next thing we swap will be equal to this integer. And then same with this, and then we'll set the first thing equal to the last one in the cycle, because yeah, if this is the last one, you want this one to move up to the first one. And so this will perform this rotation for each value of I that we want. So this one, this one, this one, and this one, let's just say, and this will essentially rotate this entire layer, because this 4 cycle will rotate all of these sides of this square. And then because we rotate each layer, at the end we'll have rotated this entire matrix 90 degrees. So yeah, let's just submit this to prove that it works. And yeah, so as you can see, it works. It's really fast, really easy to understand, and it doesn't even use that much memory, just these extra variables here, which you can even cut down if you want, but I feel like this just makes it really easy to understand. And yeah, the runtime of this would be, let me think here. So you're rotating each layer, and each layer would be a constant time. So I believe this would just be O of n squared, because if the matrix has a length of n, you're essentially just going through every element in the matrix once. So yeah, that's about it. I hope you guys enjoyed the video and found it nice. Yeah, this was the solution to rotate image. Yeah, thanks for watching, and I'll see you guys tomorrow with another video.